This will be a relatively short video, well, compared to the other ones, on the inner ring of the steering mechanism. The big challenge of the steering mechanism is that I'm trying to make it out of a thin, relatively thin, 0.89-inch plate. And that plate is going to have to be layered to make it thick enough to be strong enough to use. Off to SolidWorks. This is basically a quarter of a ring, one piece. And you make things out of quarters because they stack reasonably well. The plate is only about, I think, 10.5 inches wide. So you can't make things that are a half. That would be nice, but that would just be too big. Quarters allow you to make efficient use of the material. As you stack these pieces up, you want to phase them off by 45 degrees. The idea is to build in strength in the design. You don't want to, obviously, you don't want to stack up these gaps together. Two things to note. First off, this is not going to be machined in the mill. This shape here, which is going to house the support wheels, that's going to be machined in the lathe after this whole portion has been assembled and checked, so that basically it's smooth and round. This is a mirror image piece. When you look at this area here, this is 1/2 of an insert volume where the axle of the wheel will slide in. Bolted across this will be some holding structure that will encompass the axle. Strength-wise, when you have two pieces like this, and if these pieces, if this were to bend down on this way and down on this way, it would compress this gap together. And that would be fine. It would load up in compression, the upper piece would load in tension, and it would be able to hold a lot of load. If, however, you had a lift here and a lift over here, what you would find is that this gap would separate and there would be no strength in it. And you would only get the bending stiffness of this piece on the top. To solve that, what we really need to do is we need to cover this gap with something to add strength. And same over here. So you need more than just 2 layers. This represents the full ring. Mirror image sets. The cross ones are identical. And on the bottom, they're all identical. Now, one of the functions you have to support is holding of copper rings to transmit power from the robot into the wheel. It was going to be basically machined out of Delrin, but it's just such a complicated part that I decided to 3D print it. I do have a 3D printer that uses nylon and chopped carbon, and it's reasonable strength. It does a pretty good job. You see this structure here. This structure will house the 2.4G Wi-Fi that allows the internals of the robot to communicate into the speed controllers in the wheel. There are only two Wi-Fis needed. So this piece doesn't need a Wi-Fi holder. It does, however, need something to bolt the copper plate, the copper cylinder to, so that you have something for the brushes to ride on. All right, there is an example of the copper cylinder. Now, a little detail here, it's a little hard to see, but my idea is that I'm going to have this a flat plate, a cut, water jet or laser jet cut with a shape, and then I'm going to bend the two ends of the ring together and then braze them, and then I'll have to fill in a little gap here because you don't want to bend the copper too tight. If you soften it a little, you hit it with a little heat, you can get it to lose its temper in this area because there's going to be braze here. It will bend fairly tight, but I don't know how much until I have them made. And then you would basically bolt your wire connectors on here. So let's fill in the rest of these 3D printed parts. All right, notice that they're located above this split. They're not hyper strong, but there's a lot of material here. And so it will help the bending across this joint. On the other side, oh, sorry, last ring. On the other side, there's a piece that has the sprocket for the chain, which is going to drive the inner ring. I machine these sprockets all the time. It's not that difficult. The challenge here is that there's going to be 4 pieces, and you cannot allow one piece to slip relative to the other pieces, or you're going to get your teeth out of alignment, and or you'll break one. If that tooth happens to be uncovered when it slips, then you'll jam the chain or you'll derail it. So you have to make absolutely sure, and that's why there's a lot of, you can see there's a lot of bolts that go through here. You have to be absolutely sure that it does not move. Finally, in this part, there's this little homing piece. It's a reflector, and I'm hoping to use an optical transmitter to shoot onto this face and locate home for this spinning ring. This spinning ring can be anywhere when you start up, and so you're going to have to rotate it around to find home so that everything can be coordinated. I thought about different ways of doing that, and I just didn't find anything that had the precision that I want to have capable for steering. That's it. That's the inner ring. Lots of parts, but made out of plate.